Hi guys, this presentation is on communicating about motion, and so in order to follow along, please make sure that you have your notes labeled communicating about motion out in front of you. We're going to go ahead and get started with our first two vocabulary terms, variable and unit. Definition of a variable is a placeholder talking about a specific quantity. You might be familiar in math class with the variable x. X, of course, being a representation of some sort of number. Usually you're solving for x in order to find out what it was actually a placeholder for. In science, we often don't use x, we use variables that remind us what we're talking about. So for example, temperature, we use capital T. The unit is going to be what your variable is measured in. For example, talking about temperature, you could have the units of degrees Celsius or degrees Fahrenheit or Kelvin. We'll kind of get a feel as we move into physics, what are the standard units? They'll always be in the metric system, but for example, meters is the standard unit for distance. Not centimeters, not kilometers, but meters. So at this point, you have 7 words listed, and your job is going to be to decide if each one is a variable or a unit. So pause the video and try these first. We'll check our answers when you come back. And to check our answers, number 1, velocity is a variable. Number 2, time is a variable. 3, 4, 5, and 6 were all units, meters per second, centimeters, hours, and meters. And last but not least, number 7, displacement is a variable. Moving on to the next box, we have 3 vocabulary terms that all talk about where you are and where you've gone. So to start, the definition of distance is how far an object travels in total. The key words here being in total. Displacement is how far the object travels between the starting point and the ending point. So it really doesn't care what happens in between or the total distance. Displacement only cares about where you end and where you start. Finally, position is where the object is at a particular moment. So for example, at 2 seconds, where is the car? At 2 minutes, where is the car? I'm going to skip coordinate system and come back to it and focus on that box that says displacement equals, this is going to be our first equation. Displacement equals the finishing position minus the starting position. Remember, displacement, how far an object travels between the starting point and the ending point. So this equation can help us figure out displacement. And yes, displacement could result in a negative, that negative indicating towards the negative direction. Displacement could come up with a positive answer, meaning that you've finished relative to where you started in the positive direction. Circling back to coordinate system, defining a 0 point and directions. So you should be familiar with this just from math class, but also our first semester together in chemistry when we did a lot of graphing. It seems like such a simple thing to define a coordinate system. However, it becomes really important as we talk about motion to all agree, where is the 0 point? Which way is the positive direction? Which way is the negative direction? So we can be really concise in how we're talking. So at this time, you have a question, actually 2 questions. So if you pause the video and read the prompt and answer number 1 and 2. To check our answers, number 1 asked for the distance. Remember, distance is the total and how far you've gone. So Ms. Miller would have traveled 12 kilometers from Miraflores to FDR. Plus another 12 kilometers at the end of the day from FDR back to Miraflores, making for a total or a distance of 24 kilometers. Number 2 is a bit of a weird answer. It's looking for displacement. Remember, displacement is how far you finished from where you started. Now, because Ms. Miller finished at home and started at home, her displacement is actually 0 kilometers, which is a bit strange. A common example here would be if you're in PE class and you're running around the track. You could sprint your way all the way around the track and be so tired and really feel like you got to work out. But if you complete one full lap and end where you started, you're really tired for a displacement of 0. Flipping over your notes to the backside, you have speed and velocity. I know that this is, there's really only one word for how fast you're going in Spanish, but in physics, we really try to parse this out into 2 words, speed and velocity. Speed is pretty simple, how fast an object is moving. That's compared to velocity, which is how fast an object is moving and what direction it's moving in. So for example, you could be going 2 kilometers per hour north, 2 kilometers per hour to the right, negative 2 kilometers per hour, 2 kilometers per hour in the negative direction. And in that box that says displacement equals, we come to our next equation. Displacement equals velocity times time. You're going to have to trust me on this one. It's going to come up in your homework tonight. You're going to practice using this equation to solve for unknown values. But we're really going to understand where this equation came from when we get to our lab at the end of this unit. Displacement equals velocity times time. Now, oftentimes we don't write out the whole name of the variable. We use our letters. So another way of writing this is D for displacement, V for velocity, and T for time. At this point, you have a question to answer. Please pause the video and decide if Miss Miller running at 2.5 meters per second is an example of a speed or a velocity. The answer to this question is that Miss Miller at 2.5 meters per second, that is her speed because there is no direction provided. If the question had said something like 2.5 meters per second to the right, or in the northwest direction, or negative 2.5 meters per second, then it would have been a velocity. Moving to our final box on your notes sheet, scalar and vector. A scalar is defined as something that just has a magnitude. Now, a magnitude is a fancy way of saying it's a number. So 2 meters. 5 degrees, 400 pieces of candy. Those would all be scalars. That's compared to a vector, which is a magnitude and a direction. So this could be negative 2 degrees Celsius. This could be 20 kilometers per hour northwest. Sometimes when we write our variables, our letters to represent something, we'll use this little arrow over the top. That little arrow indicates that it is a vector, so it would come with a direction. We're not going to be real picky about this in this class, but I wanted you to know that that's a common notation, just in case you're using other online resources or see it in a textbook. So at this point, I have started to sort some of our vocabulary into scalars and vectors. I'd like you to pause the video and add velocity and speed under the scalar or vector categories. You should have added speed as a scalar. Speed is how fast you go, but does not have a direction. You should have added vector or velocity under vector, velocity being how fast you go and the direction. To wrap up, you have 4 remaining questions to answer. You are deciding if these are scalars or vectors. And you should know that number 2 is not a typo. Even if you don't know what the letter A stands for, you should still be able to decide if it's a scalar or a vector on number 2. So go ahead and pause the video and try those 4. Our answers here, mass is a scalar. You really don't need direction on mass. You can't have a negative mass or a mass to the right. That wouldn't make sense. Number 2, the tricky one, A actually stands for acceleration, which we're going to get to next unit. But even without knowing that A stands for acceleration, you could have decided that it is a scalar. That is simply because there is no arrow over the top. Remember that when you have a variable or a letter with an arrow over the top, that would indicate a vector. So since this doesn't have an arrow, it must be a scalar. Number 3, velocity, how fast you go and the direction. The direction would make it a vector. And 25 miles per hour northwest would be a vector simply because the direction, northwest, is provided. So at this point, take a look back over your notes. Write down any additional notes or questions that you have in the margins. It would be a great time, if you do have questions, to pause here and ask your teacher to clarify any vocabulary that you're unsure about.